Hello again, welcome back to Stats Breakdown. The article that we're going to use today is also the article that you are using to practice for your CAP assignment, and it's also your group discussion for week 5. The article is called Randomized Controlled Trial Comparing Tailoring Methods of Multimedia-Based Fall Prevention Education for Community-Dwelling Older Adults. As always, this is in your Blackboard and available to you, so I do suggest you read through this as this is what everyone is going to use to attempt their first CAP and get used to the format as well as how to adequately critically appraise literature. So as the name suggests, since it's stats breakdown, in this video only, we will only review the stats so that you become, again, more familiar with it and it doesn't seem so foreign to you as you're going through it. So I'm going to actually go straight down to page 703. Okay, because on page 703 is kind of where I would like to start to point out some things that are important to the statistical design of a study. First and foremost, this was a 3-group randomized controlled trial. That is important to know because that will help you decide, or I should say, help you better understand why they used what inferential statistics that they used. So, in this case, they used a 3-group randomized controlled trial. Keep that in mind. That is important. Now, participants and setting. Here. They also only used 53 community-dwelling older adults. That's also important. So this 53 community-dwelling older adults is your sample size. The design, this 3-group randomized controlled trial, is what's going to help you understand why they used certain inferential statistics. Now, let's walk down. There's everything in the article, of course, is important, but I just kind of want to point out again, focusing on the stats. So I'm going to go down to data analysis, which is on page 704. Okay, so let's take at the data analysis because this is where we're going to kind of look at things and better explain them so that you're comfortable with them as you begin to critique and critically appraise this research article. So they stated we calculated means and standard errors of means for age, number of fall threats identified at pre-test and post-test, and a number of new fall prevention behaviors. Counts and percentages were computed for sex, independence and community access, fall status, fear of falling, and the number of new fall prevention behaviors. Fall status was determined on the basis of retrospective self-report of falls experienced in the past 12 months. Okay, and you can continue to read, but I'm going to go down. To examine the baseline differences in participants, okay? So to examine baseline differences in participant characteristics among groups, we conducted this here, as you see, X-squared test, or Fisher's exact test for categorical variables and univariate analysis of variance, which is an ANOVA, for age. Okay? Then they also used a couple other additional tests that we have not talked about yet to confirm that all continuous data continuous variables were normally distributed. So as you see, level of measurements and type of data never go away because those again help you determine which inferential statistics will be used. And here as they talk about them. Now let's go up for just a second. Actually, let me just double check one thing. Oh, I forgot to mention one other thing. We conducted a mixed design repeated measures ANOVA to investigate group times time effects on fall threat knowledge. Okay? They also analyze group times time interactions and determine differences between pre-test and post-test knowledge within each group. They also conducted, I'm down to page 705, separate post hoc repeated measures, ANOVAs, controlling for fall status. Then they also completed analysis of covariance, which covaried baseline pretest knowledge and controlled for fall status. So as you can see, they use quite a bit of different type of statistics. So what is the important thing to understand? What did they do and what does all of this mean? Well, essentially you want to know, did they use the right test first and foremost? Because one of the questions that you're always asked, or one of the questions you should be focusing on within while you're critically appraising an article is, were the appropriate statistics used? So that's what you want to take a look at. And to understand that, you need to, again, know exactly what each of these are. So let's go back up here. First and foremost, let's talk about means and standard errors of means. Okay, we know what a mean is. We know that a mean is an average, right? It is the average of a particular data set, and that is what they're providing. Now, generally, you would see the mean and standard deviation provided, but in this case, they gave you the standard error of mean. Now, I know you're probably wondering what that is, so we're going to talk about that. Okay, let's go over to my handy dandy stats workbook here, and let's talk about this a little bit. We know what standard deviation is, right? We know that it measures how closely all of the data is in the data set surrounding the mean, okay? How spread out and where it fits within there. Generally, you would see in a given set the mean given with a standard deviation, right? But in this case, this article provided you with the mean and standard error of mean. So the question now becomes, well, what is the standard error of mean? And, well, why did they use it? So we know that the mean is the average of a sample, while the standard error mean is a measure of how accurately that mean reflects the mean of the total population. So why is that important, or why are we using that? Well, first thing first, let's go back and talk about the sample size that they used. I'm going to go back up to page 703 and take again a look at how big was the actual sample that they were using. The sample that they were using for this study was only 53 participants, okay? That's something to take into consideration, because what we know from standard deviation is that smaller populations tend to make a more narrow curve. So the larger the population, the more accurate the standard deviation is. So in this case, a standard deviation, or using mean and standard deviation versus using mean and standard error of mean, may not give us exactly what we're looking for or be as accurate as we would like. So this study decided to use for their three groups, which I'm going to come back to, for age, mean plus or minus the standard error of mean. So how accurately their mean fits within the actual the mean for all values. So the standard error of mean allows us to quantify that difference, okay? And let's just give a further example to better understand. Let's say you have two samples, okay? Here are two samples. You have, consider this a weight score of some type of intervention. Doesn't matter for that purpose. But the point is, these scores may seem a little higher with one large drop, while these scores are a little more spread out. But both of them have the exact same mean. So the question for us then becomes, well, looking at this, we need to figure out where exactly do the mean, or how accurate the mean fits in if you compare the mean of all values, okay? So you would, in this case, use a standard error of mean to help you better decide what would be the correct option to go with, okay? And I didn't provide you with the data set, but I can in another, I will in another video, but for this case, this is just to kind of help you conceptualize why you would use a standard error mean. Two different data sets that could provide you with the same mean. In this case, you would want to use a standard error of mean to help you decide that information. Now, let's go back up and let's take a look at the figure on page 705. This study utilized 3 groups. That's important because what do we know about the number of groups or comparing the mean of groups, right? That'll let you know which statistical test should be used. And as we know, we do have a handy dandy handout that tells you what test is best to use when, right? So we already know a bit about t-tests, but we also know that a t-test only looks at the difference between 2 groups. Okay? But the ANOVA, right? This can be between 2 or more groups. In this case, we have 3 groups. So as we see, they did utilize ANOVAs, which would make sense, correct? Now, going further, they used repeated measure ANOVAs to evaluate fall threats knowledge. Okay, let's talk about that for a minute. What is a repeated measures ANOVA? Well, from our book, we can see that on page 66 of chapter 4. If I zoom in a little bit here, if I zoom in, our book talks about a bit about repeated measure ANOVAs. So a repeated measure ANOVA is used to compare the differences within one group at 3 or more groups, okay? So I'm going to say that again. Compare the differences within one group at 3 or more groups. That's important to know because as we see, if we go back to the article, we did mention that, right? They did want to look at interactions and determine the differences between pre and post-test knowledge within each of the groups. So hence they're telling you this is the reason why they used it, and you can make sense that yes, that or you could in your head say yes, that does make sense. So they're using the appropriate test in that case for the continuous data. Now, we have some additional ones. Now let's talk about some other ones that they used. So we did point out the fact that they are using on page 705 repeated measure ANOVA for the evaluation of fall threats knowledge I'm just repeating it, but they did use repeated measures ANOVA to evaluate fall threats knowledge, okay? But earlier they did mention that they used mixed design repeated measures to investigate pre and post tests of effects of fall threats knowledge. So you have it where it's technically stated on 704 and 705 similar. But at the same time, it's a little different because I want to point out the fact that they mentioned repeated measures ANOVA, but they also repeated mixed design repeated measures. So they're telling you that they used different types of ANOVA to determine what they were looking for because they were not only looking at group comparisons, but they're also looking at in-between group comparisons, which is important to note. And not to mention only that, but they're looking at that between 3 groups. That's 2 or more groups, right? So let's go back to our handy dandy book and let's take a look at a mixed model ANOVA. So we know from our chapter 4 that a mixed model ANOVA compares both between groups and within group differences simultaneously, providing an interaction effect. Now I'm just zooming out a little bit, and they can also provide separate results of the between group differences and within group differences. Example, main effects. Okay? So this is the reason why they're using that. Again, this is to help you understand why they're using inferential statistics. Now, I would also like to go back and just clarify because I said something that technically wasn't exactly true. When I mentioned repeated measures, I said Compare the differences within one group at 3 or more groups, but I meant to say time point. Stay tuned for the next video.